Hi, my name is Paul Daramola, and this is an introduction narration for my Urban Supermix thesis submission. Throughout history, the criteria for a city's development has evolved, but it is usually affected by social, political, environmental, economic, and technological advancements. Thus, there has been an overall evolution in terms of a city's land use. So, a city is never complete. It has a beginning, but no end. It is a work in progress, always waiting for new things, usually buildings, to be added, and new characters, usually the people, to move in. Thus, the key features that define the characteristic of a city are usually the buildings and the people that use them. These series of illustrations are part of a 20-step DIY guide for building a city from scratch. We're so good at it now. In a historical context, my thesis employs a year 0 to 100 concept, which considers worldwide criteria for city development since the end of World War II in 1945, signifying year 0, and 2045, signifying year 100. The first few years after World War II saw the widespread of manual labor jobs and factory workers. However, our current trajectory is evidently leading us to an era of artificial intelligence. We started with dual-dimensional mode of transportation, but now we are thinking of flying cars and underground tunnels. And finally, the post-World War II years enhanced the mass production of housing, but now we are looking toward mass production of machinery and data storage centers. Now, unfortunately, advancements in technology has also played a major role in what we now know as the age of consumerism. Simply put, we buy and throw away because we can. So the understanding is that individuals can now produce even more waste in one lifetime of consuming products than ever before, such that British households now produce an estimated total of 26 million tons of waste annually. Now, in that regard, plastics are still one of the most problematic household waste that is still being produced, with this diagram showing how many UK councils still struggle to recycle their plastics, Newham Borough being the least in 2018 at 14%. All this is a single branch of the issues that have now led us directly to the declaration of the climate emergency, with the prioritization of recycling as a mitigation strategy. So thinking of solutions, and as we edge towards a future of electric-powered garbage trucks, my thesis considers the potential of automated waste management systems in new master plan projects. Here are a few concept images illustrating my initial thought process. The Supermix proposal. The site is in Newham Borough, but specifically the Royal Docks, which has a significant industrial heritage, where buildings like this turn into buildings like this, and then get acquired and turned into schemes like this. Now, this process is understandable in relation to the inevitable expansion of London outwards into Zone 3 and 4, also where this site is located. Typically, such schemes categorize of residential and commercial buildings. However, this thesis theorizes a supermix. This refers to a concept that aims to include industrial uses in the same ratio as the typical mixed residential and commercial uses, but centered around automated waste management systems. The site has a few existing and derelict buildings, but most notably a Tate & Lyle golden syrup factory, which has been assumed to be acquired in the near future, in line with the current trends in the Royal Docks. After going through some mixed options, the eventual conclusion is to propose a 57%, 28%, and 14.3% for residential, industrial, and commercial uses, respectively, combined to make up a total of 50% of the site's land designation, and the remaining 50% as public space filled with lovely greenery and openness. The vision diagram best illustrates how automated waste management is incorporated into the master plan. Waste is produced from previously purchased items and disposed through a tubing system that runs through the residential blocks. There are different tubes for different types of waste. They then go underground into an automated collection and sorting system that separates the plastics and other types of wastes into barrels. The barrels with plastics are then transported into a proposed on-site plastics processing factory. The recycled and processed pellets are then sent to the repurposed factory to be turned into new synthetic polystyrene-based products, which are then sold in commercial retail stores, and the cycle continues. In total, this thesis features 3 out of 4 proposed structures and buildings. Firstly, the residential block with the integrated waste collection system. The underground waste collection and sorting system, complete with a viewing gallery to showcase this technology to all who are interested. And finally, the multi-level repurposed factory, which includes the factory at the ground floor level, co-working spaces on the upper floor levels, and a plastics waste museum at the topmost level, all connected by an eccentric sculptural spiral stairs as a crowning jewel within the building. In regards to construction, the aim is to retain the external shell of the existing factory only and to remove all internal floors, columns, and the existing roof. This is predominantly because drawings of the existing situation have been impossible to acquire during the process of this thesis. Thus, steel frame construction is proposed for the internal refurbishment of the repurposed factory. Other building material, including concrete, is to be acquired from surrounding demolition sites and recycled. The roof is to be rebuilt, but to the same form as the existing in order to preserve its heritage, although it is not currently a listed building. However, structurally, it will be constructed from spruce, glued, laminated timber. A passive ventilation strategy has been largely incorporated, predominantly for the upper floors, but mechanical ventilation for the factory at ground level, as controlling the room temperature is imperative to ensuring optimal performance from the machinery and factory workers. All in all, this is a scheme that is proposed to fit within the year 0 to year 100 timeline by encouraging the influence of future technological advancements in new master plan schemes. Thank you for listening, and I hope you find my portfolio enlightening and informative. Finally, I have included a walkthrough video of the repurposed factory within the portfolio. Please do have a look, and I hope you find it useful. Thank you.